Okay, so here's a couple of problems. These are pretty simple ones just to get started. We'll build our way up. So the objective is to construct the shear force and bending moment out there. Now I'm going to save a little bit of time just to get started on these simple ones, and I'm just going to tell you what the reactions are. I'm sure you could probably find these if you had the time. The first problem here on the left side is just a cantilever beam with a load P at the end. The beam is of length L. I think you'll find that the reaction is up and equal to P, and that the moment is in this direction and equal to PL. Now, before we go any farther, what kind of shear force is this? Positive or negative? That's positive shear force. What kind of bending moment is this? Positive or negative? That's negative bending moment. So we kind of know our starting points for both our shear and bending moment diagrams. Now we get out here on the end, since there's an applied load P there, then we're going to have some idea of what the shear is. What's the bending moment going to be at this free end? Should be 0. So we kind of have to start and finish for that. So remember our differential relationships are that the change in shear is the area under the load curve, and then that the slope of the shear diagram is given by the load. So let's use those two things to help us build the shear diagram. So starting here, we usually work from left to right. So starting on the left-hand side, I look at the shear, and what do I know the shear to be? We just talked about it. It's positive P. All right? What do you think the shear on the right-hand side is? Right before P. So if you can imagine a little chunk of the diagram, and I draw positive shear acting up, you'll see these two things are equal. So that means the shear at the free end is positive. So that means it should be also P. That's just from what I can see. I know I've got to start at P and end at P. That doesn't give me a lot of choice in between. Also, it says that the change in shear between these 2 points should be the area in the load curve. And what is the area under this load? It's 0. So there is no change. So that matches. And then it says the slope of the shear diagram is given by the load. And the load is what? All the way across the beam. 0. So 0 slope is a horizontal line in our graph. And there's your shear diagram. So everywhere in that beam, there's positive shear equal to P. Any questions about that? So let's do the moment. So now that we've taken the loading and constructed the shear diagram, we're now going to take the shear diagram and construct the moment. And we're going to know that the change in moment between any 2 points is the area under the corresponding shear diagram, and that the slope of the moment diagram is given by the value of shear. We're going to apply those to this. Also, we're going to look at things we know about the moment. So starting here on the left side, do we know something about the bending moment? We do. It's PL. And what kind of bending moment is that? Negative. We're going to start at minus PL. And then back, what about on this side? Do we know the moment here? Well, there's no applied moment like this problem, which we'll talk about in a second. So that means the moment is 0. So we're going to start at negative PL, and whatever we construct here, we better end back up at 0. So first let's do this. The change in moment between the 2 points, say from the left side to the right side, is the area under the shear diagram. And what is the area of the shear diagram? Well, it's a rectangle, so it's going to be base L times height P, TL. And it's positive. So negative PL plus PL, boom, gives me 0. That's great. So that definitely works. Now what's the shape of the moment diagram? Well, the slope is given by the shear. So what would be the slope right here? Well, you go up and you read the shear value, which is what? Positive P. What would be the slope out here in the middle? Well, you go up and you read the shear value, which is positive P. In fact, it's positive P everywhere. So it's constant slope, and it's positive. It's got to be this shape. In fact, if we looked at it, the slope would be P to 1. And there's our moment diagram. So once you have those things, notice we didn't write any equations. All the calculations we did were in our head, basically the area under a rectangle. And now we know what? We know two critical things. Where's the maximum shear in the beam? Oh, anywhere. And what would the value be? It would be P. What's the maximum bending moment in the beam? Negative PL. And where does it occur? At the connection. So you can now take that information and design connections to withstand the shear and other kinds of connections to withstand the moment. All right, so let's keep a cantilever beam, except now no applied force, but an applied moment. So if I were to assume a reaction here at the fixed connection, and I would sum forces in the vertical direction, what would my reaction be? 0, right? Because there are no vertical forces applied, so there's no vertical reaction. What about the moment? Well, equilibrium tells me that the reaction moment needs to be equal and opposite, right? You see that? That's the reaction moment to this applied moment. So when I go to draw my shear diagram, what's the value of the shear at the start point? 0. What's the value of the shear at the free end? 0. Now, according to my relationship, the change in shear between any 2 points is the area in the load curve. And what is the area under the loading? 0. So if I start at 0 and I add nothing to it, I'm still at 0. And the shape of the curve should be given by the load. And the load is 0 everywhere. So really there's no shear in this beam at all. 0 shear. Now we're going to do our moment diagram. We're going to use our shear diagram. And also, what do we know about moment? What's the bending moment at the start of the beam? Bending moment. Is this a positive bending moment or a negative bending moment? It's a positive bending moment. So it's going to start at M0. And look over here at this right-hand side. Is this a positive or negative bending moment? Also positive. So I'm going to end at M0. Now, according to this, these have to be satisfied. So the change in moment between any 2 points is the area of the shear diagram. What's the area of the shear diagram? 0. So M0 plus 0 is M0. That's good. And the shape of the curve in between here? Well, it's the slope of that curve is given by the shear value. And what's the shear value everywhere along this curve? 0. So that means that this is a horizontal line. So this is a situation where under this loading, the bending moment is constant throughout and creates no shear. Any questions about those two? All right.